Hi all dear students, welcome back to our channel Mechanical Engineering Made Simple. Right, so there was no video for 2 days because of hectic work due to the ongoing examinations of OU and JNTU. So you must be knowing about them. So let us continue our preparation. So today we are going to start from the bit 801 and then we are going to discuss up to 810. We already crossed 800 bits and probably we will be reaching 1000 bits question for your AMV examinations. Okay boys, if you are not subscribed, please subscribe, like, comment and share among your groups and contacts. Definitely, if you think that it is helping you in your preparations or it is helping you in the revision of the subject or it is helping you learn from starting from fundamentals, please like, share, comment and subscribe my channel. Okay boys, so let us continue. So first question today is the chemically correct air fuel ratio among the following is equal to, it is equal to 14.5:1. Okay, so all others are okay, something like to just misdirect you, 14:5, 14.5, okay, 1.45:1, 0.07. So 1 by 14.5 is going to give you it is 0.07 approximately, but he is asking air fuel ratio, so it must be air should be 14.5 times and fuel should be 1 time by volume or by weight mass. That's your answer. So let us mark the answer. That is your 14.5:1. Next question, a CI engine can be considered as a, so in the CI engine, so normally only air is compressed compared to the air fuel mixture from carburetor which is taken into the cylinder and compressed in case of an SI engine. So your CI engine is basically a constant air supply engine. That's your answer. Let us mark it. In CI engine, the air fuel ratios are either, so you know that most of the times the requirements of air fuel mixtures are either too rich or too lean. So your answer must be too rich and too lean. So stoichiometric air fuel ratio is very rarely required. Okay, so next, the indicated thermal efficiency with leaner mixtures. What is indicated thermal efficiency, by the way? So indicated thermal efficiency, okay, for any engine or for any device, the efficiency is nothing but your output, what you are getting by the input which you are giving. Okay, so here in case of any engine, output is the power and input is the heat energy, right? So indicated thermal efficiency is equal to the indicated power which is available, that is the power available in the cylinder by the power supplied by way of burning the fuel per second. That, okay, so it is something like IHB by N thermal indicated efficiency is equal to, or is equal to your indicated horsepower by mass flow rate into the specific heat of the fuel. Right, so the indicated thermal efficiency with leaner mixture, it is going to increase. So normally most preferred one, your leaner mixtures are preferred normally, so it is going to improve the indicated thermal efficiency. Right, next question. For higher friction engines, the brake fuel specific fuel consumption, this is a very good. So in this video basically we are discussing about the very important questions about your engine performance parameters, something like your BSFC, indicated thermal efficiency and some other things, etc. And also we are discussing some important questions about your combustion chambers. There are two main important combustion chambers we are going to discuss about the bits related to that also. Okay boys, next question. For high friction engines, the brake specific fuel consumption would be, so definitely if the friction is high, the engine is going to consume more fuel. So normally this is called something called, it is going to be called mileage. So this is a common man term, that is your now common language we are going to use the term mileage. So is it more or less? So normally we are interested in more mileage vehicles, yes or no? So if the specific fuel consumption is more, it is then we can call it as less mileage. Your engine or your vehicle is giving less mileage. If your brake specific fuel consumption is less, then we can say that it is giving a good mileage. Okay, so with that knowledge, let us continue further. For higher friction engines, the brake specific fuel consumption will be normally larger. Next question boys. In the Whelan's method, Whelan's, it is not M, it is printed as M but N. In the Whelan's method used in IC engines, the graph between the fuel flow rate and torque is extrapolated to. So basically Whelan's diagram is a diagram between the torque on the x-axis and the brake or specific fuel consumption on the y-axis, right? So here this is a good question boys, once again please underline this. So in this normally the fuel flow rate and the torque, it is the graph is extrapolated to the negative fuel consumption. This is a good question, it was asked in many number of examinations. So your answer is negative fuel consumption. The Whelan's line for a swivel chamber, so just now I was referring to combustion chambers. There are two combustion chambers normally. Okay, your swill chamber, combustion chamber, and also direct injection combustion chamber. So here is a comparison between the Whelan lines for swill combustion chamber and direct injection combustion chamber for your CI engines. So the Whelan's lines for swill compression ignition engine as compared to a direct injection injection type is, so it is, in fact, it is more straight. So your answer is more straight. Next question. In SI engines, the turbulence required for air fuel mixture is obtained by, is it squirrel or is it squish or is it quash or is it will? Only the C and D are only simple English terms which are no way connected with your IC engine, okay, operation, etc. But swirl and squish are very, very important things as far as your SI engines operation is required. So in SI engines, the turbulence required for air fuel mixture is obtained by what is known as squish. Squish. Right. In induction swirl, this is one type of swirl. So what is correct? So is it going to, is it that single orifice is required, nozzle is required but less excess air, or is it that multi orifice nozzle but less excess air? Is it that a single orifice nozzle but high excess air, or is it that multi orifice nozzle but with high excess air? So here in this induction swill we are going to have multi orifice nozzle, that means having orifice or nozzle having more number of holes than one, that is called multi orifice nozzle, but it will need also high excess air. So your answer is D. Answer is D, multi and high. Okay, boys, last bit for update before actually we conclude. So boys, my request is that I have made number of videos for your competitive exam, especially for AMV. Okay, we are reaching almost, today I think today's video is 77th video on my channel. You are having approximately 80 videos and probably we have completed 80 videos, okay, approximately 10 questions per video. So we will be having, I think so, we will be having 20 more videos, more than that. That means 20 into 10, another 200 questions. So we will be crossing 1000 bits, which will be very useful for your examination. So you can check for easily, and if you think that they are really helping you, or is it useful, my channel is helpful or useful for you in your preparation, please like, comment, subscribe and share among your groups and contacts. So today last question is, in the induction swill, there is, just now I told you, it is going to use a multi orifice nozzle but and also high excess air. High excess air. Last question for today. In the induction swill, there is, for producing swill, so is there any need for small additional work, or is there any need for high additional work, or is there no need of additional work, or nothing, the additional work is nowhere related to, something like none of these to your induction swill. So actually in the induction swill, there is, for producing wheel, there is no need of additional work. This is a good question once again. Okay, boys, so remember that in the induction swill there is no need of any additional work. Okay, boys, so once again let us stop today video here. So as I told you, a number of videos for you are available on my channel, some for GATE, some for your APPSC, TSPSC, your municipal vacancies which are likely to be announced shortly. So so please be with the hope that notifications are going to come once the elections are over. So don't worry. So the more the delay, the more the time you get for your preparations. With that positive note, let us stop and wish you all the best once again.